Welcome back, guys, to another video, and you are watching Kylo. I think you kind of noticed what this video is going to be about, and if you saw my last YouTube video about my schedule, well, yeah, this should also be self-explanatory. Today is Mess Around Saturday, number one. Uh, so we're gonna be experimenting with some stuff and all that, maybe just, like destroy Earth and that. But just a quick note, I noticed that well, actually, I think some of you might know that I have a live stream planned May 5th. Now, if you watch my YouTube schedule, you know what this is, or if you've seen that video, you might already know. Now, you see it says Gaming Month. By that, I just mean like that's the. I guess I should say that's like the gaming video of the month. I didn't really know how to put it in other words. If I can find a better words for it, or I just don't think it's good enough, which honestly I think I do, because yeah, yeah, then I'll change it. But for right now, it says as gaming month. Just know that means that that's gonna be the gaming video of May. But yeah, so you see, we got three IO games planned: Mope IO, Slither IO, and Dipe IO, which is the thumbnail, which I'll be playing a lot of. And I think a few of my people that are like communicate well on Discord will also be joining. I plan the stream to be about like 1 to 3 hours. Hope it'll be a fun one. That's like actually it's in less than 3 days now. Because for me, it's gonna be at 2 p. The stream starts at 2 p.m. and we're already 17 minutes past 2 p.m. But yeah, so we have a little less than 3 days. But anyway, now let's get on to the main part of the video. So the first thing I want to mess around with is a star called by the name R163A1. Let me see if I said that correctly. Oh, no. There we go. Can I select it? Also, I'm not using a mouse, so I might be like, a little rigid while trying to use this, or I don't even know how to put it. Now, the thing is about this, the star is the most massive star in the universe. Well, that we have discovered, of course. And this mass is actually wrong. It's supposed to be a binary star system. I think they're both the same size. So I don't know how far they orbit from each other. Let's actually look that up real quick, why don't we? So, oh, frick. Okay, yeah, I was trying to find out how to sing. I don't know why. I just do that in my spare time. R136A1. Oh, it's actually RMC. Oh, wow. Okay. Uh, binary system. Uh, so it turns out is it actually a triple star system? I don't know. Well, I don't really know actually. Okay. Oh wait, no, that's space engine. My bad. So we're gonna put a binary orbit, like maybe like around here. I really don't know how far they orbit from each other. Actually, I really don't. Okay, hold on. Now we're gonna create, wait, make binary orbit, balance momentum, create Berry center. Let's see how this works out. So what we're gonna try to do is find the habitable zone of these two stars. Now there's a problem in Universe Sandbox. It actually happens with this star. There's no habitable zone. Like no matter how far you go out, there is no habitable zone. Like I don't even know how far that is now. Oh my god, what happened? Okay. Frick. Okay, there we go. So we have to find the habitable zone, which is actually pretty far out. I don't know if I'm pretty sure Earth is gonna freeze trying to do this, but we're gonna do it anyway. And you have to go insanely far. I think the habitable zone is like 1800 AU out here, if I'm not mistaken. Oh, no, I said to focus on Earth. That is not Earth. So we're gonna see how Earth does with these stars, and they look insanely bright. Now let's see how Earth's doing. Oh, it's heating up. Whoa. This isn't even the habitable zone. We're like 1800 AU out. You could definitely see a different tint in the atmosphere. Yeah, yeah. So yeah, this is definitely too hot. It's for some reason we still have clouds at 100 degrees Celsius. I do not know why. We shouldn't even be alive. So actually, we gotta go farther out. I don't know where the exact habitable zone is. I would assume we have to go super insanely far out. Let's see. So actually, this one's cooling down, but it was at an insanely hot temperature. I want to put this to degrees Fahrenheit because I just want to see how hot it actually is. Oh, 101. Oh, whoa, that is definitely hot. So let's see how the stars look. It looks insanely bright still. Yeah, because just to let you know, these are one of the most luminous stars, and actually the mass is wrong. It should be 315 actually. 320 masses of sun. But I don't really bother to fix it. Because if I do, then the Earths are gonna crash into it because I changed the mass. So yeah, I've also changed the gravity too. Let's see how this one's doing. Let's see if it still cools down. And now it's getting frozen. That's like, well, well, we can say that the habitable zone is probably out here. Oh, and that is not too far. Now let's see how this Earth does. So I do not know what's going on. I think we just had a huge glitch. Well, okay, we're not gonna really find out what really happens then. Yeah, I think Earth just gave up on life, to be honest. Well, that was a failed experiment. Let's get on to the second experiment, shall we? Now we're gonna use with the Universe Sandbox. I'm gonna do three stuff in Universe Sandbox and three things in Space Engine. Hopefully, if I can come up with ideas. Uh, so let's see. Well, hold on, let's go to Earth and Moon real quick. I know this has definitely been tested and it's true, but I want to show you. So, oh, planets in between Moon. Whoa, that's a lot of rings. All I want is the Earth and Moon. I don't know what's going on. There we go. Now we're gonna put where's the moon? Where is the moon? And also, we will be destroying Earth too. Actually, I might do a little more than three things. I don't know how long we've been recording, but that's okay. Probably will. Let's try to land on Earth, shall we? See if we can. Whoa. Whoa. Oh, no, I don't want to save simulation. No, I don't want to save it. Okay, whatever. So let's see. Let's start with Mercury. We're gonna put Mercury right there. We'll put Venus. Oh, that's a little tight. Mars. And we're gonna play big boy Jupiter. If I can find Jupiter. Uh, can you? Oh shoot, that is big. This is like gonna take up most of our space. So we're getting pretty close to the moon. I don't even know where the moon is at this point. I don't think we're going the right direction, are we? Okay, I think we might be. Let's just go here. Saturn next. Uranus. And Neptune. So wow, this is I don't think this is. Oh, yeah. Well, that would make sense. I I think we screwed this up. Yeah, we did screw this up. Well, if we put this back here, then we would see that it does reach the moon's orbit after all the other planets. So now it's another failed experiment. I do not know why my experiments are going so bad. But what we can watch is the chaos unfold, of course. Well, that is minutes per second. Like an hour, 55 minutes per second. Oh wow. Okay. I do not know what happened there. Now, next thing I want to test out is watching the Betelgeuse super. No, actually, no. Let's watch Polaris. Let's see about Polaris. Hold on, let me. Polaris. Oh, there we go. I do not know how many actual light years it is. So actually, we're gonna use Betelgeuse, which I believe Beetle. Oh, Betelgeuse. Okay, hold on. Oh, memories bring back you. Oh no, that is not close. That is a little too close. So Betelgeuse is about 150 light years. Let me just see how long we've been recording for. Okay, we've been recording for 13 minutes. Okay, that's fine. So Betelgeuse is about this far away. And also has its other Orion belt partners, but we're gonna see what happens when we make this go supernova. Which is about a billion years from now, because it is gonna be exploding pretty soon. And then the last thing I want to test out is what it is making the Earth and Sun switch places. Yeah, that's gonna be pretty fun. Okay, where is Earth? Because we're watching this from Earth. Now where is the Betelgeuse super? Where is the Betelgeuse nova running? Oh look, a Quawar. I like that name actually. Where is Betelgeuse supernova? Well, it's somewhere. We know that. I don't know exactly where. We might have to let time pass a little bit. Oh, there it is. There it is. There it is. Okay. So there's the supernova. I don't know if the supernova is gonna look like this, but I know the thing about this about Betelgeuse's supernova is that once its light finally reaches us, it will shine bright at night, and it'll be bright enough to be seen at day as like we have a second sun. And it'll also shine, I think, 7 times brighter than the full moon. Like it's supposed to do that, which is gonna be kind of cool. But it also mean that we could actually heat up a bit from this. I'm not really sure how heating up works, but I assume there also are some negative effects to this too. But it'd be cool to think, oh, wait, what's that second sun doing in the sky? Now, I think the effects last for like a week or so. I don't know how long they'll actually last. I think most say it lasts about a week. I'm pretty sure it probably lasts a little longer, maybe a little longer than that, but yeah. So when it lasts, it would be pretty cool, but sadly, I'm not gonna see it because it's supposed to be in another million years. I don't plan to be on here for another million years, and I don't think I'm gonna live that long. But anyway, yeah. And also, I'm probably gonna have to get my charger soon. And there we go. Okay, anyway. So we're back. We're gonna watch this Betelgeuse supernova remnant. And we're gonna watch as this thing slowly reaches us. You know, in real life, it shouldn't actually affect us. But, yeah, it's not 150 light years. Wait a minute. It's actually 450. Oh, shoot. I'm thinking of, what's that star? Pegasi. That's what I'm thinking of. Oh my god, I'm so dumb. So I, so obviously today has not been my day. I'm forgetting stuff. I put Betelgeuse 300 light years closer than what it should be. It should actually be like, yeah, it should be that far away. I could still see Betelgeuse from here. Okay. Basically, what I'm saying is, well, I messed up today. Let's agree on that. Okay, well, I can't change anything about it. I just had a bad day today while recording this video, but, yeah. Let's go to Space Engine, shall we? Because we have not been there yet. Like, so let's go we're currently at Alpha Centauri. I could probably find the sun from here if I wanted to. Yeah, sun's gonna be right here. I don't know why it's a solar system. So, first galaxy I want to visit is M101, which it doesn't actually have its name that is referred to. Space Engine, which is the world, not the whirlpool. I mean the pinwheel. So this is from inside the pinwheel galaxy. We're gonna have to go a little bit faster if we wanna see some stars. So we do got a few galaxies here. I'm pretty sure they're random. No, they're not random generated actually. So this is from inside the pinwheel. It gets pretty packed in the center, obviously, because, well, that's where most of the stars are in a galaxy. So this is the pinwheel. It is 206 light years in diameter, which is about twice the size of the Milky Way. So if you put this thing next to Milky Way, it's going to be much larger than the Milky Way. And then the next galaxy I want to check out is the largest barred, yeah, largest spiral galaxies. No, that's not it. That's not it. Um, what is what was the Condor's galaxy other name? Let me find out real quick. Because I don't like how they had the Condor galaxy this way in Space Engine. It really made me upset. Oh, 6872, okay. 6872. This is 520,000 light years in diameter, and it's supposed to look like this. Yeah, with a few other galaxies next to it. This is what Space Engine gives us. And personally, I've seen other few random January galaxies that look exactly like the Milky Way. They have the Milky Way shape and everything. Honestly, it's sad. Now, I kind of want to see how far I can see this up to. So this is about 23. So even from 23 million light years, I could see this galaxy plain as day. Now, normally the other Milky Way could be seen from about 120, 7 million light years. Or like, until like it went, to the blue phase, like it became brighter again. It looked like a star. Wow. So this is from inside the Condor Galaxy, or what is basically another Milky Way, which is a poor representation of it, which is really sad. Uh, yeah. The next one is IC 1101, the largest galaxy in the universe that we have discovered. I believe it's also the most luminous galaxy too. In fact, look. We're like 225 million light years, and I could still see this galaxy plain as day. And this is where it somewhat turns into like a dim yellow thing before it slowly disappears. Now we're about we're a billion light years from it, like about Milky Way from it. What like Milky Way is from it, and I can still see this galaxy. Probably find Milky Way from here. Are we on the right side of the galaxy is the real question. Milky Way might be on the other side. Okay, we're on the right side. Just off by like 300 million light years. Okay. So actually, Milky Way is about 5 million light years. You can see it away and see that's plain as day before it becomes these blue things. So small Magellan Cloud becomes a bright blue object not before a million light years, like about 800,000 light years. And here's the Milky Way, galaxy we all love and enjoy, where we live. Well, that's basically the video. I didn't. This is my first mess around. Like slowly as I get into mess around in any gaming videos eventually, which I do, which probably will go bad too. Like that's when I'll begin to learn. Like it's gonna take some time. Plus, I have not live streamed ever, so we'll see how this live stream works. I'll see if I can pull it off correctly, hopefully. But anyway, I hope you stay in tune for my next video that I'm gonna upload tomorrow. From now on, my Instagram is just gonna be showing two videos. The one on the left is gonna be my last video, and then that will be on the left, and then the right side will be my